to another episode of Digital Oil and Gas. My name is Geoffery Cann. And top of mind for operators in the oil and gas world today, by far, is the importance of reducing emissions on work sites and to improve the productivity and quality of workmanship, given the increasing pressures of regulation and pressures on the various financial providers to the industry to reduce emissions everywhere and anywhere possible. And so it's important for the industry to explore every possible way to cut its emissions impact and to look for ways where those emissions can be reduced cost effectively and quickly. And one that I've discovered through my various travels in the industry is the presence of contaminants in products like drilling mud. And those contaminants have a significant wear effect on the drilling equipment and the pipes used, drill casing. And if there was ways to kind of make that more cleaner products working their way through the drilling apparatus, it would have a positive effect on the industry. And I'm honored to be joined today by Roger Simonson, who has developed a really innovative technology that targets this exact issue, and have a conversation about what this all means and kind of show us how this technology works. So Roger, let me welcome you to Digital Oil and Gas today.
Good to see you again, Geoffrey. Quite enjoyed our last chat, so I'm looking forward to this one.
Yeah, we did 2 podcasts, and the problems with podcasts, what I like about podcasts, they're quick and easy to do, but the problem with podcasts is that you have to visualize what we're talking about. And what we're going to do today is actually show some video where we can illustrate more precisely what this technology does and what it's all about. But let me, just as to begin though, Roger, if you don't mind, just share a little bit about your journey to get to where you're at, and why are you devoting your life's work at this stage? You could do a lot of different things, go golfing, but you're devoting your life's work to solving these problems in the industry.
Well, over the last 20 years, we've developed magnetic filtration technology that is highly effective in removing both ferrous and non-ferrous contamination from all types of media, from crude oil, refined products, water, chemicals, even air. And we come across a problem in the drilling business for unusual premature wear of the fluid ends in the high pressure pumps and the drill string components, the drill bit, wearing out ahead of time. And we did some testing starting over a year ago. And when we last chatted, we talked about this testing. Well, we've completed a major stage of it, and the results have been absolutely phenomenal. It's going to have a major positive impact on the cost of drilling wells. It'll reduce the cost for the drilling contractor and therefore for the operator.
And it has to do with the drilling mud itself. And for those who are not familiar with how the industry works, the mud is actually used to both lubricate the mechanical movement of pipe, casing, and drill bit in downhole, and to serve as a media to lift cuttings back through to the surface as the bit is moving and grinding away at the subsurface formations. But you've mentioned, what you've said, Roger, though, is that somehow is giving rise to ferrous contaminations, steel, if you like, that's contaminating the mud. Can you elaborate what's happening here? Like, why is this happening?
Well, the drilling industry has increased the speed of drilling. There's higher temperatures, higher pressures, higher demand on the whole system. And I don't, from what the observations I've seen in the industry, no one's really realized especially with horizontal drilling, the pipe wear from the casing and the pipe contact all the way through for kilometers or miles underground. That wear contamination that's coming off, along with the iron that comes from the formation itself, comes back and saturates the mud. And it's tremendously small, mostly under 4 or 5 microns. In some of our testing, the majority of it was under 1 micron. Well, this stuff acts like sandpaper when it's being pushed through at high pressure and speeds through the whole drill string and into the drill bed. So people didn't understand that when you shut down to check the pipe thickness to see if it's suited for the drilling that you're doing, and or if it's wore through or thinner, it has to be replaced. Well, all that metal is going somewhere, and it's finding a home in the drilling mud. And the last test we did, we had a volume of mud of 58,000 gallons. It's invert oil base, which weighed a total amount of 923,000 pounds. We removed in a matter, I believe, 3 days of constant running, we removed almost 14,000 pounds of iron wear contamination, iron and steel. That's exactly what's wearing their whole system. So once we got it cleaned out, the test results identified on average a 53% increase in operational life of their fluid end components. Very successful, very happy customer.
Yeah, you can imagine the handling of that drilling mud, the contaminant in it has to be addressed. The number of incremental testing having to be done that you could avoid because you now are removing this abrasive contaminant from between the walls of the casing and the drill stem. All of this adds up to significant benefit to the operator. Where's the emissions angle here? In this.
So when you're drilling, you're running generators. They're either running diesel fuel or they're running natural gas to engines to turn their generators. When they're shut down for a component failure or a pipe check, you're in flat time. The generators are still running. So you're having emissions that you don't need. And also to cue in on one point, natural gas leakage or fugitive emissions are referred to occur very highly in dirty natural gas going into a combustion engine. The combustion is not efficient, therefore the methane gas is exhausted out, therefore not good for the environment. And that can be all resolved by cleaning that gas to a high level, and that means cleaning the black powder contamination down to and below 1 micron particle size.
So how do people clean the drilling mud today, Roger? Are we using a sort of a traditional mesh filter or a fabric filter, and we're cleaning it that way?
No, it'd be virtually impossible to clean invert or oil-based mud. Traditionally, they use shaker trays to take all the big pieces out of the formation that's coming back. And also they use what they call centrifuge filter systems. Well, unfortunately, they're only efficient down to about a 40 micron, maybe 30 micron if you're really lucky particle size. The damage is done by the contamination under 10 microns and mostly under 1 micron. So that flows right through a centrifuge.
Yeah.
No one actually had any idea how much of this metal was in their mud. So they knew there was some iron in there. So they would put what they call ditch magnets in. But they're very unsafe to work with. They're heavy, cumbersome, they're hard to clean, and they're made with a magnetic element that's not very powerful. So you don't collect anything under 10 microns. You need a very, very powerful magnetic field to pull a submicron particle through a viscous product like drilling mud.
Yeah, I'm just trying to imagine the force you have to apply to be able to withdraw such a tiny particle. It would have to be more than just your standard fridge magnet feature. We're talking a magnetic capability here that's of some significant capability.
That's one of our biggest challenges, is getting people to understand our technology is a magnetic technology that uses magnets within it that creates 10 times the magnetic field strength it would normally have. And that's what allows us to filter and remove very, very small particles through viscous oils like drilling mud or crude oil, etc.
Any thick product. Now, I said at the outset I wanted to show a little video of what this actually looks like. So I'm going to put this up on the screen. Roger, I want you to do is just talk us through what we're seeing on the screen as we watch this little video. And so it starts off with a clear plastic container. What's in there?
So we have our magnetic filter elements inside this housing. We use a tempered glass so we could actually see the buildup of the black powder or contamination as it enters the housing. It's operating at 25 kilometers an hour, and we're simulating a natural gas flow application. And we're introducing the black powder into the housing with the air. And you can see that it collects on the elements where the magnetic fields are the strongest. And you can see it build up very, very quickly.
Now, how do you clean or is this this is the cleaning process here? Yeah.
Yes, right now we have a patented cleaning process that cleans all the black powder contamination off of the elements and allows them to be turned back into service very quickly.
And that's, I guess that little shot was what the contamination actually is, or what it looks like.
That's correct.
And how do you dispose of, once you have that contamination now, it's like a powder or a grit. How do you, I assume that's a landfill disposal, or is there something else you need to do with it to dispose of it?
Well, on a drilling site, what we've observed, the drilling contractor mixes it with the contamination coming out of the centrifuge, and it gets taken for disposal or rehab somewhere in the system.
Standard disposal, yeah. Let's talk a little bit about this this non-productive time in a drilling application. How much? Any ideas to how much time is on the dime here as to what operators are devoting to running a round trip, testing the equipment, cleaning it, repairing it? Has anybody come back to say this is how much savings they're getting?
Well, on our first test, the savings that were identified were an extension of production values by 50 to 55% on average. So that means drilling longer, which results in the well being drilled to completion for their side of the process. So that if you can save 2 or 3 days of drilling costs, that's a lot of money on land drilling rigs. I think you could be anywhere from $30,000 to $70,000 a day cost.
Yeah, it's your day rate for your rig is going to be the driver there, for sure. How have you done some studies to prove out that the microns are the cause of the submicron particles are the cause of the abrasion? How does an engineer, engineering world wants to show me the numbers, show me the math? What can you back that up with?
Very good question. The testing backed it up very quickly. Once we got the mud cleaned, the operational time increased up to 55% before they had to repair components and or replace components in the drill string and the fluid ends on the high pressure pumps. Very quickly identified that the return on investment was happening right in front of them.
Yeah, pretty easy to measure. If people want to learn more about this technology and how it works, you showed a lab bench version there. The equipment behind you is all, of course, encased in steel. Can you just tell us what we're seeing behind you?
I don't know if you can see it in your camera, but this is a CleanMud housing here.
Uh-huh.
And this is what goes inside of it over here. These are the magnetic elements full of contamination right now. It requires cleaning. We use it for a display. But it's a large housing like any other filter housing that you would have on site. We have fully automated and semi-automated systems that work as a kidney loop on the drilling mud reservoirs or tanks.
And the obviously the scale and making sure the equipment fits the infrastructure at site. It doesn't look like it's particularly large. I assume is it skid mounted when it's delivered to a customer, if that's how they wanted to deploy it?
Yes, absolutely. Skid mounted with a containment skid. So if there's any leakage, it collects in there. We have two different sizes for the main drilling rigs that are in service. We're focusing now, working with the deep drilling, the horizontal and offshore as well. This technology will save tremendous money in NPT or flat time for offshore applications.
Yeah, the drilling requirement there, the rates on those rigs are extraordinary. So any time saving would be valuable. Let me pop up a screen here that just provides some contact details so that people, if they want to reach you, this is where and how they would find you. Thank you, Roger, for sharing with us that innovation. My name is Geoffrey Cann. Tune in again for another episode of Digital Oil and Gas. We'll talk about other innovations going on in the oil and gas industry. Bye for now.